Thank you for attending our session this afternoon. My name is Steve Whittam. Whittam Associates has been a support arm of Autodesk for the last 35 years, working with end users in manufacturing, supporting the woodworking industry. It is our hope for the next 4 sessions that we will provide solutions that will assist engineering departments to become more efficient at utilizing digital prototyping. All of the software that we are using today is downloadable in a trial for 30 days. Demo sets are available, and on the screen now are the URLs of where you can download them. If you have any questions, please contact us directly. We've decided on presenting 4 sessions. Session 1 is on Carcass design. That is this afternoon. Session 2, in several weeks, will be on joinery techniques utilizing the same design. Third session will be hardware and library development, and the final session will be material creation and cut listing, including 2D drafting as well as bills of material. Please let us know if you feel that the sessions that we're running meet your particular needs. Thank you once again for attending our session today. After you've loaded all your software, Inventor first, Woodworking for Inventor second, the next step is to launch into Inventor. We launch into Inventor, and normally the first thing that we would like to do is to make sure your project file is set correctly. So we go to Projects, and you could see that I have no project files at all at this moment. So if you would go to Browse, go to your computer C drive, there'll be a directory called Woodworking for Inventor 2020 Design, and there is a project file called Woodworking for Inventor 2020 projects.ipj. If you double click on it, it sets up your world. So for example, it is saying where your folders are going to be, in other words, where the data is going to be stored. The fact that we're adding a new material library for Woodworking for Inventor, an appearance library, and a material library. Your workspace is going to be called Projects, which is underneath the top level folder. Libraries already installed. Folder options are already set up. So that's the first step. Second step now is to set up Inventor so that it is tailored a little bit more towards the needs of the individual. So what I normally do is I go to Tools, Application Options, immediately turn off Show My Home on Startup because I don't really want to use this. It does take resources. I turn the delay, select other delay to 1 second, not 2 seconds. You can change the background color if you so desire. Under Display, you can change the zoom behavior. So if you're used to other systems that the mouse wheel zooms in and out and you reverse to what you like, this can be changed. And under Sketching, I like picking Auto Project Edges for sketch creation. Turn that on. And the Look At tools I turn off. One more thing we do, under Part, I say I want to sketch on XY plane. I don't see a need, personally, to have to pick the plane I want to sketch on every time I start. So we do all those things. So if I say File New now, start a standard part, I'm ready to go. Once Inventor has been set up for your particular needs or the group's particular needs, the next step is to consider the usage of a template that can be modified, manipulated, adjusted to engineering's requirements. I'm going to be using one of the ones I've created for my general type projects. The samples of these are available on a download. All you have to do is request it. Be happy to send it. But they're very simple, and I'm sure that one can create these on their own. But if anybody is having any difficulties, as I said earlier, demo sets are available. So I'll pick new, and I created a folder called Start Parts. And I created a template called Start. Now, of course, it could have had any name. If I click on it, the first thing that happens is that it automatically creates a part, centers the part in the screen, and brings up a ILogic dialog box. And the first three options in the dialog box are already controlling the part. So if I want the width to be 40 inches, it's 40. If I want the height to be 30, 30. And if I want the depth to be 20, you can see it's adjusting. Now you can also notice that every time I do that, it centers it in the screen automatically. So if I was out here somewhere, zoomed all the way out like so, and I said that was 45, it zooms back in. So there's less rotation, less manipulation of the model, the less steps that I have to go through to just do my task, the better off I feel I am. There are other fields in here that are fully configurable also. For any of the group that came from 2D systems, many of them had layers and layer names, and they were defined by colors or descriptors or line types and the like. Well, in our world, we can have parameters just waiting for us to use them, just like layers that have nothing on them until I need them. So it's in a similar function that I'm considering that. And of course, I can have as many fields as I so desire. You can also see there's fields down here that have nothing in them yet. But again, it's a start point. How did I do that? The first thing I did was I went into parameters. Now, if your world is set up so you don't see the parameter tool, you right-click, show panels, and you can turn parameters on and off. Make sure you turn it on. If I look at the parameters, you'll see that I have parameters height, width, material thickness, vertical 1, vertical 2, and so on. And these are nominal measurements, but they're being controlled. How are they being controlled? They're being controlled through ILogic. So if we went into Manage, ILogic Browser, over here on the left-hand side of the screen, you could see that these are controllable also. Again, we've done this in previous sessions, but if anybody's having any difficulties, please let us know. Then we'll send a separate video in relationship to that. The one thing that we also have done in our system is we've said that when you start up a session of Inventor, bring up the dialog box. Call up this dialog box as soon as you open. And that's usually not something that happens. The other thing that happens also is if I change the value, you can see that it centers it back on the screen. So that is what we developed the rule. So in ILogic rules, there are two rules that we use. One is called zoom fit, and this is all there is in this rule. This application.actView.fit. You can just type it in. That's number one. And number two, show form. The rule says ILogic form.show dimensions. That's all this is. So two simple rules that we've added to the template, so that every time I open up or start a new file, this is what gets generated. But how did it get triggered? Well, under ILogic, there's something called event triggers. And you see the rules that you've generated. So if I wanted to, as after a new document is created, show the form and zoom fit, all I had to do is drag it and drop it. You could see changing of part geometry. Zoom fit is the only thing that happens. Doesn't need to open up the dialog box. So here are the events that you can set up to trigger these things to happen. And they work quite well. The depth is going to be 12 inches. In our series of seminars, our goal is to try to replicate a piece of furniture that was created at the turn of the century. This is a Gustav Stickley sideboard. And what looks fairly simple in terms of its construction, once you pull it apart, it's quite a bit more intense. If we take a look at the drawers, you'll see that they're dovetailed. You'll see you've got wrought hardware that has to be created. You've got a door, hinges on it, glass stop, quite a number of different things. If we look at the joinery, it gets a little more intense. The joinery is, of course, blind dados and through tenons, a construction technique that was used quite often. Let me just do an update, put it all back. Okay, as we turn the piece around, we'll get to see a little bit more of what's going on here. I'm going to take the back piece and turn its visibility off so that you can start seeing that there is a rabbit, a housed rabbit all the way around. And you also will notice there's sliding dovetails, blind dovetails that have to be created. So for all intents and purposes, this is a simple system, a simple item, but there's quite a bit to it. When we look at pieces of this nature, we also start thinking about the time frame in which it might take to create them. Utilizing some of the techniques that I'm going to show you, this piece of furniture should probably take you no more than an hour and a half to create from square one. So, and it should be fully parametric, thusly change. If I want to change the opening of where the door is or the drawers are, or change the width, the length, the height of the unit, I should be able to do that fairly quickly. Thusly, a design of this nature, even though it's a one of, should not really take very long whatsoever. Let's take some measurements of this unit. So if I go ahead and measure the width of the whole unit, 48 1/4, the depth of the unit, 16 inches, and the height of the unit, 39 inches, that would give me a good sense of where to start. The openings, let's measure them, and they're about 12.5 inches. Again, these are approximate sizes, and if we build the cabinet correctly, piece of furniture correctly, we'll be able to change these immediately once we start our construction. The construction of the unit is quite simple. We'll get started by creating a brand new start part. And as we set up previously, you could see that it comes in centered on the screen. Dialog box pops up asking us what is our total width. It's 48.25. The height is 39. And the depth of the unit is 16. So that's where we start. Now, Woodworking for Inventor has some wonderful tools, and there's something called skeleton dress up. And skeleton dress-up works with solid bodies. The technique of solid bodies came about quite a number of versions ago and can be used in a very speedy way in the creation of original design. This, in combination with top-down modeling, bottom-up, skeletal modeling, solid body modeling, all these techniques allow us to build quickly and efficiently. So, again, if you've downloaded Woodworking for Inventor, you have these tools. I'm going to first go to Skeleton Dress Up. I'm on a part. You can see it's part 2. There's one solid body in it, which is this bounding box that we just created, and I picked Dress Up. It asked me to select the solid that I want to work with, which is this. And what I'm going to do is I'm going to create faces or panels out of every single plane on this particular shape. If I say select all faces, you will see that arrows appear on every single face, and these arrows will automatically tell the system what direction the thickness of the material is going to be added. So obviously if I touch on the cone, that means half is going to go inside, half is going to go outside. That's on the center line that this plane is. And if I pick it once again, that'll go to the outside. Pick it once again, it goes to the inside. So very controllable. I'm going to hold the Shift key and touch the face, which basically says that I will not create the face as a panel. It's asking me what will the thicknesses of those faces be, and I'll say that should be material thickness, which will be controlled by this value right here. So in other words, we're going to build this unit, and then at any time I can change the thickness of the entire unit by changing one value. If we have multiple thicknesses, that's why we might have different values. Now looking at the browser, you'll see that it's one solid body, and that's this unit here, and it's a part file which I haven't named yet, and you can see it's a single cube. If I now hit the plus sign, what it just did, I'll X out, what it just did is it created 5 panels, top, bottom, left, right, and back. You'll notice here in the browser under solid bodies, you'll see that there are now 5 solid bodies that are each of the panels, and the one on top, solid 4, or it could be solid 1, it depends on how many you made in your sessions. This is the bounding box that is being controlled by the dialog box of ILogic. I have 2 ways of turning that off because I don't need it anymore. The first way is I can go into visibility and I can say all skeletons, and that's considered a skeleton, I want to hide. And I just hit it, and you can see the visibility of this turned off. Or I could have come over here to the browser, right-clicked on it, and turn the visibility on and off in this fashion. So both ways work. You'll also notice that at the top of the browser, the name of the part is still part 2, but you now see there's double cubes here. It's not an assembly. It is a single part with multiple solid bodies in it, and that's what this is referring to. At this moment, I can come over here and I can start naming it right panel. I touch it, and you can see that it's naming it top panel. I can right click on these and say properties, okay? And I can do it here if I want to, instead of just clicking on it. So multiple ways of controlling it. This is the bottom. And this is the back. We also have the ability to change colors if we wanted to. In other words, if you want to differentiate it even more, back panel. You could by right-clicking on the item and going to properties and changing its color right here, okay? Again, Lots of approaches in doing this. At this point, I'll pick Save. I'm in the project directory. Again, my project file told it to go into Woodworking for Inventor 2020 Design, go into the project folder. I'll say I want to create a new folder, and I'm going to call it Seminar Series. But again, whatever you would like. And I'm going to call this, let's call it Cabinet, let's call it Furniture Master. So now you can see it's Furniture Master here. What's also interesting about this is that if you wanted to turn off solid bodies, you can come over here at any time and say turn off its visibility, and its visibility is off, or turn it on. What's also nice about doing this is you could say, okay, the bottom panel, I'm going to right click on the bottom panel and I'm going to say hide all others, and that becomes available. Right click on it and say show all. Again, just a couple of quick techniques in accomplishing end goals. Now our unit is pretty basic at the moment, and if we look at the cabinet itself that we're trying to replicate, you could see that this shelf is 2 1/8 inches down from the top, and this bottom shelf is 3 3/8 up. Okay, so we basically created it totally square, and now we're going to clean it up a little bit. So utilizing simple tools, direct edit. In 3D model we say direct edit, direct. I can either move a face or a solid. I'm going to move a solid. I'm going to touch the solid I want to move. I'm going to grab the head of the arrow, and as you can see I can move that whole solid up or down, and I did say that that was going to be 2.125. I just moved it down. Flip it up a little bit. I'm going to touch the bottom and move this up. Just be aware of negative and positive. Minus 3.375. And what we've had, of course, is our basic unit that's already been taken care of. Okay, so we have a couple things here that are a little unique. Okay, so the first thing that we notice is that we have these intersections that we might, well, can't work. Okay, so when we're building solid body modeling or using this technique with skeletal modeling, what we try to do is butt everything together first correctly, and after it's butted together and it's accepted and approved, we'll then do the joinery. A little bit different than many of Inventor users out there, but you're going to find this is fast, quick, simple, and by the end of the session the hope is that you might want to adopt some of the techniques that I'm showing at this time. So in skeleton dress up, we've done a dress up. We have 3 more operations. We can clone, that's copying. We can trim, that's like AutoCAD trimming. And we can miter. So I'm going to trim. When I trim something, it's going to ask me select what I'm trimming, and I'm trimming this and I'm trimming that. Okay? And select what you're trimming it to. I'm trimming it to here, here, and here. And I'm going to pick OK. Pretty easily done. You could see that this is now quite accurate in what I just accomplished. Okay, let's go further. Let's now trim this back. And I'm going to trim it to the left side, top, and right. Looks good. Really not doing any sketching, just working it through. Okay, now we have a couple more things we need to do. This top piece, bottom piece, a little bit different than what the final one is, but we have to create a dado down the back of this. If I look at the back of the unit, you could see that I've got a dadoed back and a solid piece here. So a lot more complicated, and the dado goes all the way down to the bottom. So first thing is I need to reduce this by this depth. So again, we'll go back into direct editing. I'm going to not move a solid, I'm going to move a face. If I move a solid, the whole panel goes with me up and down. This is a face. You can just pick, direct edit, face, pick, take the head of the arrow, and you can see I can move it up and down. But what I like about this, I can say snap to. I'm going to snap to the actual corner and pick OK. So that's now done. Okay, let's spin it around, look at it further. Now I have to create dados. The easiest way to do this would be for me, let's turn off everything but the back panel. So I can right click on back panel in the browser. I can say hide others, and that's available to me. Just the panel, get everything out of my way. I'm going to say thicken and offset. I'm going to touch this face, and I'm going to say that that should equal material thickness divided by 2. So what I'm doing here is I'm planning for the future. So if, for example, the thickness of the material is not 3/4, it's 1 inch, then the dado is going to be equal to half of the thickness. So no matter what the thickness changes to, it's always going to be halfway into the side. And I pick apply. And I'll do exactly the same thing on the other side. And apply. Okay. I'll right click. Well, I could do it multiple ways. I can just highlight all these panels on the left side, the solid bodies, and turn their visibility on. Very good. Next, trim. Skeleton dress up, trim. What am I trimming? I'm trimming the left side and the right side against the back. Let's save my work, and let's take a look at what just happened. If we look at this now, and let's turn off the visibility of the back panel, you can see that that worked out great. Perfect dados. Yes, you can build clearance into this. Works out very, very well. Let's turn the back on again, visibility. Now this piece, this back or the bottom, is going to be the bottom here. So if we turn on the back, you could see I ended there, but I kept this long so I can cut the dado. So again, what I'm going to do here is just do a direct edit of a face, grab the head of the arrow and push, and say snap to there, and pick OK. That's now complete. Let's pick save, save my work. What's interesting about everything I've done up to this point, okay, is that this really takes minimal time. What's also interesting about this, if I wanted this to be not 48 1/4, but I wanted it to be 24 1/4, I just adjusted it. Everything here is adjustable. So by saying that, we now have the variability of construction, and with the right CAM tools, this can be out to the shop floor and cut and nested within the next couple of minutes. I know I'm not done, but this gives you a good sense of the construction and a method. Now let's go further with this. If I wanted things to change in thickness, let's say it should have been 1 inch. I just adjusted everything to 1 inch. If I say it's a 1/2 inch, okay, 0.5, it's now a 1/2 inch. What's interesting about what I'm doing here is take a look at the data. It's always going to be halfway into the part. So if I measure the distance from here to here, it's a 1/4 inch. And if I change it to 3/4, 0.75, it's now 3/8 if I measure the distance from here to here. It's 3/8, okay? So again, the techniques I'm using are universal, could be used everywhere, by themselves or in combination with others. A tremendous time saver. Okay, so we're at the point to add some of the dividers, the verticals and the horizontals. If we look at the original cabinet piece of furniture, you'll see we have 2 verticals, 1 horizontal, separating the drawers from the cabinet, you know, the larger areas. These could either be 3/4 of an inch, these could be 1/2 inch, not sure, but there are definitely different possibilities here in the creation. These look like they're a little thinner than that, so we're going to make it two different operations to accomplish that. Okay, so we're back to our model. In skeleton dress up, we have those 4 major tools: dress up, clone, trim, and miter. If we do a clone, which is a form of copying, and I touch this left panel, you can see that it automatically did an offset of whatever was last used in a positive Z direction. I'll hold the Shift key and touch it again to deselect. I'm going to touch this one, and you can see the same thing happens. It always moves in the positive direction. Now, I can type in a value if I want, like 4 inches, and it won't be as controllable, you know, through a dialog box, but still very, very usable and still editable within the browser, because if you notice, the browser is picking up all the different naming conventions we used with the tools that we have created. And just like Inventor, it's doing exactly the same thing. So the comfort level of getting used to tools like these is very good, and probably within half an hour, 1 hour, or an afternoon of using it, I mean, you've mastered a large part of how this works. So what I'm going to do here is, instead of giving it 4 inches, I'm going to go ahead and say I want that to be horizontal panel 1, which will equal this guy here. And I'm going to use a different thickness. Now I'm going to use the same thickness, M thick 1, M thick, and the verticals will be thinner. Okay, and here I'll hit the plus sign. Okay, that leaves me in the dialog box. I'm now going to touch this, and it's not a horizontal panel, this will be a vertical one. So then these will be controlling it, and this will be M thick 2, and I'll pick the plus. I'll come around, touch this side, and this is going to be vertical too, and hit the check mark. Okay, so we're out of the system right now, and let's trim this up. Okay, so if we say trim, I can trim either one at a time or both. I'll pick this, select here, here, and there, and that. 1, 2, and 3. Of course, just showing you I can do them at the same time, or I can do them independently. Now, taking a look at vertical panels, okay, this is going to be 12 inches. And the other one, if we want it, as you can see, fully adaptable and changeable. Now, to show you that we can still use normal Inventor concepts here, I'm going to create, of course, a sketch. I'm going to create a rectangle, 2 rectangles, okay? I'm going to dimension one of these, and I'm going to say that equals, list the parameters, m thick. And I can say equal if I want to, and I can equal, of course, that with this, or I can just do a dimension and say m thick also. So we're doing the same thing. Now, if I want this to be utilized so they're always equal, no matter what the width is, one of the tricks that are available, if you don't want to use any kind of formulas, let's just draw 3 lines that are attaching these together and make them equal. So this and that are equal, this and that are equal. So now those are equally spaced no matter what the width of the unit is. Some people like to take all 3 of these and say your construction line. Some people go further and say they should be collinear. Doesn't hurt, but available. And then I'm going to extrude this. Say extrude to the back wall. And it's a new solid, very important. New solid. And pick OK. I can take what I just did, share the sketch, and extrude this guy too. Back, new solid, and pick OK. And then let's turn off the visibility of the sketch. So what's interesting about that is if I now change the value from 48 to 40, of course those will stay completely equal. All openings will be equal no matter what I do. Works very well. Let's go back to 48. So everything's adjustable at this point. All the shelves, all the dividers, all the fronts except for the 2 far ends are set in 1/8 of an inch. Using standard tools like thicken and offset, what I'm going to do is just touch the face, 0.125, make sure I'm going in the right direction, hit apply, 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 Okay, and I think I got them all done. So fairly quickly generate all that information. Yes, there are multiple ways of accomplishing the same task, but for all intents and purposes, saving 4, 5, 6 seconds I don't think makes a big difference. A couple more pieces of trim will finish our cabinet off, or at least our carcass off for the moment. We'll take a look at that, and we could see that this front face, this back face or stretcher, and this top piece has to be created. Okay, so let's go ahead and sketch on this. Let's create a rectangle. Sometimes it's easier to sketch freely and add a constraint afterwards, like we have here. Okay, let's add this dimension, and that'll be material thickness. Let's go ahead and add this dimension. That'll be 0.75. And this dimension here, which is 2.375 at 2 3/8 inch. Let's extrude this. Let's extrude it 2. And give it a, or tell it it's a new solid, and pick OK. If we look at the solid bodies, they're starting to add up now. Okay, so this guy here, as I click on it, you can see the name appear. So we're going to say that left, let's give it a name. This will be left drawer vert. And this will be right drawer vert. And this will be kick. Okay, let's go to the top. Do pretty much the same thing. We're going to sketch on this. We'll draw a simple rectangle here. Dimension it. Material thickness. And extrude this. And say extrude to there. It's a new solid also. I'm going to take the top of this and just thicken it a little bit. Let's make it 0.75. And then fill it. Material thickness. It's interesting because you can pull up this information of these variables at all times and pick OK. So now you can see that the radius stops and starts exactly where we have that previously done. Okay, I think we just have one more piece of trim on the back. Yes, we do. I'll sketch on that. Let's just draw a simple rectangular shape. Let's do a constraint, collinear constraint. And extrude it all the way to new solid and pick OK. So that looks pretty good. I'm not worried at all about the coloration at the moment. It doesn't make a difference. As we turn this into an assembly, we'll be assigning materials. This is all for development at this moment, okay? Let's go ahead and do a little bit of detail on this. So I'm going to say create a sketch. Let's draw a simple rectangular shape. Let's add a dimension. That'll be 1 inch. Let's make that 2 inches, the spacing. That'll be equal. And let's extrude just that, and we'll cut all the way through. It's never going to be over 1 inch, so either way would work for us. Let's come over here and do a simple fillet. It remembers material thickness as the option. Taking a look at it now, that looks pretty good. And that is now in place and operational. We have 2 more things we have to do. We have to do the cutout in the side. Just small detailing and a radius up in here. Okay, so to complete this particular carcass, we need to do a little bit of trimming of one of the panels. If we take a look at what I'm referring to this top radius cut and this bottom foot cut. And if we take a look at them in elevation or side view, you could see that they're not a true radius. This is an ellipse. And down here, you could see that there's a straight line, okay, and then an ellipse. So we've got a couple unique things that are going on here, okay? And they are not the same panel. They're 2 different panels. There's a left and right. I didn't copy them, so that in our bill of material and our cut lists, which we are going to go into, it'll say left panel, right panel. If I change one, it doesn't change the other. Okay, so a lot more control than many other systems. So let's go ahead into the model and see how we're going to do this. So I'm going to sketch on this face, take a look at it, and I'm going to create an ellipse. So under the circle tool is ellipse. I'm going to just start up here and create a simple ellipse and just grow it a little bit. Now, obviously I didn't touch a corner or an edge. I didn't draw any construction lines. What I'm now going to do is I'm going to say tangent, 2D constraint. The top of this will be tangent to the top of the panel, and the face or the front of the ellipse will be tangent also. So I know that this corner piece will be usable, or it'll act as a closed loop. I'm going to dimension this, and that'll be 1.25 because I basically had documented the unit. This unit also was in fine woodworking a couple of years back, so I've used this in other instances of our system. Okay, so you could see that, different approaches. Okay, that's 1.25, and if I dimension it this way, okay, it'll be 3 inches, minor and major axis. Okay, so we want to cut off this piece. So I'll use the extrude command. I'm using an alias, E for extrude, out of the box. Touch that. And I'm going to flip it. I am going to cut it. And I'm going to say cut through all. Now the problem with cutting through all is that because these are solid bodies, they do not automatically cut into the second solid body unless you touch solid and touch what other solid is participating. And now you see that's going to cut. The dialog boxes in 2020, Inventor 2020, are different than the dialog boxes in early releases, but all pretty much the same tools are available there. There have been additions, of course, in the new version, but you'd have to look a little closer to find the tools I just described. You have to allow a second solid to participate. And that's done. Let's go ahead, sketch again on the bottom. And I create multiple sketches. I don't like applying a sketch here and in the same sketch tool do the cutout here and the cutout there. And the reason for that is I'm complicating my sketches, and also maybe I want to turn one feature off without turning the other one off, and that's why I will separate my sketches. Also, for diagnostic testing, if there is a problem, it'll be easier to delete one or suppress one to verify what might have possibly caused a problem. Let's go ahead and create a simple rectangle, because I'm going to need these vertical edges to work with. I'm going to dimension that. That's 2 1/4. And this guy here is going to be the same dimension, so I can just touch the original to make them equal. And that centers the part, center the cutout, of course. And this will be 0.5. I'll now draw an ellipse. I'll stay right on the line, come across, and open it up. Okay. Now I know those they're not touching, but I can use coincident, touch the point at the tangency here, and I might be right on the midpoint. No, I'm not. Okay. Let's do it again. Point and point. That's better. Find the point and the point. Great. And then add a dimension here. And that's going to be 1.25, somewhat equaling the one on top. Using another alias for trimming, X, I'm going to touch here and trim this away. So what's left is the cutout that I'm going to use to, well, the profile I'm using as a cutout. I do not necessarily have to change this line to a hidden line. If I didn't want to in this particular situation, all I'd have to do is extrude 1 and 2, get them both. Similar what I did at the top, I'm going to say I want to flip it, cut it the other way, all the way through all, pick solid and touch the second solid that it's cutting through and pick OK. And we have it pretty well done. Testing is next. So for testing, probably one of the easiest things for us to adjust to verify whether we've done it reasonably well is to change the depth. A lot of things are controlled by the depth. So if we come back over to assembly depth and say it's not 16 but it's 12, you can see that our elliptical shape absolutely adjusts correctly. If we change the height from 39 inches to 30 inches, works fine. Change the assembly width from 48 to 40. Change the vertical panel from 12 inches to 10 inches. So everything, my entire model is now, at least at this point, able to be totally controlled parametrically, so that if I needed to create a family of these with different sizes, quick, easy dimensional changes would change my entire model. And as an Inventor user, if you have been using Inventor, you know all the drawings would update also.